Hello guys, welcome on Tesla Adventures. In this video, we are going to find out the magnetic field at the center of a uniformly charged, non-conducting, rotating sphere. So you can see that this is a hollow sphere on which the charge is equally distributed on the surface, and this is a non-conducting sphere as well as it is rotating about this axis with an angular velocity of omega. So we know that to find out the magnetic field at the center, we have to consider an element which would be a ring. You can imagine that there would be a small ring on the surface of this sphere, and this ring is making an angle of theta like that, and this radius is capital R. Okay, so if we find out this distance x, then we can say that x will be equal to r cos theta, and the radius of the ring, which is small r, will be equal to r sin theta. Okay, so first of all, this is the dimensions of the ring, and this small width of the ring dl, so dl will be equal to r d theta, where d theta is this angle, small angle d theta. So if we find out the charge on the ring, then charge will be sigma into area of the ring, and sigma is given as sigma, and area of the ring will be 2 pi r into width, which is dl. So dq will be equal to sigma into 2 pi r, and dl will be r d theta, and small r is r sin theta. So dq will be equal to 2 pi sigma r square sin theta d theta. So this will be the charge on this small ring. Now due to rotation, there will be a small current in this ring, and that current, average current, will be dq omega by 2 pi. So it would be equal to sigma r square sin theta d theta into omega. So I'll be writing it down here. So this would be sigma r square omega sin theta d theta, cancelling 2 pi with 2 pi. And the current in this ring is this one, and magnetic field due to this small ring is mu naught I, which is di, into r square divided by 2 r square plus x square to the power 3 by 2. Okay, so let us use the next page. Yeah, so dB will be mu naught di into r square divided by 2 r square plus x square to the power 3 by 2, where di is sigma r square omega sin theta d theta. Di is sigma r square omega sin theta d theta. Okay, so and r square plus x square, you can see that x square plus r square is equal to capital R square. So dB will be equal to mu naught sigma r square omega sin theta d theta into r square. Now small r is r sin theta, so it would be r square sin square theta divided by 2 r cube. So cancelling this with this one, so dV will be equal to mu naught sigma omega r by 2, and it would be sin cube theta d theta. This is the magnetic field at center due to this small ring. To find out the net magnetic field, let us integrate dB, and the limit of integration, now you can see that integration will be with respect to theta, and the limit of integration will be equal to, you can see that if theta is measured with this line, so the smallest ring will be at this point, and at this point theta will be equal to 0. Okay, and till this point theta will be equal to pi by 2, obviously, and at this point if we go further on, so you can see that at this point theta will be equal to 0, and at this point theta will be equal to pi. So the limit will be equal to from 0 to pi. So it would be mu naught sigma omega r by 2 sine cube theta d theta. Limit will be from 0 to pi. And to integrate this, we know that first of all mu naught sigma omega r by 2, this is mu naught sigma omega r by 2, and let us write down sine cube theta as 1 minus cos square theta into sine theta into d theta, and let us assume that z is equal to cos theta. So dz is equal to minus sine theta d theta. So b will be equal to mu naught sigma omega r by 2, and this will be equal to z square minus 1 into dz, and b will be equal to mu naught sigma omega r by 2, and integration of this will be z cube by 3 minus z, and the limit of z will be from 0 to pi. So let us use another page. So b will be equal to mu naught sigma omega r by 2, mu naught sigma omega r by 2, and this is 2, yeah. And again if we substitute back the value of z, then it would be cos cube theta by 3 minus cos theta, cos cube theta by 3 minus cos theta, and the limit will be from 0 to pi. So b will be equal to mu naught sigma omega r by 2. If we substitute the value of pi in this equation, you can see that it would be minus 1 by 3, and it would be plus 1, as well as if we substitute the value 0, then it would be 1 by 3 minus 1. Okay, so you can see that b will be equal to mu naught sigma omega r by 2. This is 2 minus 2 by 3. So 2 minus 2 by 3 will be 4 by 3, and b will be equal to 2 mu naught sigma omega r by 3. This will be the magnitude of magnetic field due to this sphere, rotating sphere at the center of the sphere. Thank you.